All right, so this is 5.2, rational functions, okay? So I'm going to start this lesson out by actually graphing a rational function. And it's just going to start getting you thinking about what they look like, okay? So everybody look at that equation, and I want you to tell me, what is the domain of that equation? Everybody tell me. X can't be 0, okay? So everybody just write X cannot be 0 right there for the domain, okay? And now this is a very elementary, low-level way to graph. And we're not going to graph rational functions with a table of values. But since we don't really know what we're doing yet, we're going to use a table, okay? So if X was a 1, then you'd have 1 over 1, which is 1. If X was a 2, then you'd have 1 over 2, which is 1/2. If X was a 3, then you'd have 1 over 3, okay? Now let's take a second and plot those points. So everybody go write 1 up 1, write 2 up 1/2, write 3 up 1/3. What would 4 be, guys? A 4th and a 5th and a 6th. And would that ever touch the x-axis? It's never going to go to 0, so it's going to look like that, okay? Okay, well that's great, but what about between 0 and 1? So let's choose like a 1/2. Can anybody tell me just off the top of their head what 1 divided by 1/2 is? What is that? It is a 2, okay? So if I go right 1/2, I go up 2. You guys, what if I went right 1/3? What would I do? If X was 1/3, then Y would be 3, yeah? And then 4, and would it ever get to the 0? No. So it would look like that. Now that's only half my graph. Because what if all these x's, what about the left side? Well, if all those x's were negative, then 1 over -1 is a -1. 1 over -2 is a -1/2. So the y's would just change signs as well. So I'm going to go left 1 up 1, or pardon me, left 1 down 1. And then left 2 down 1/2, down 1/3, down 1/4, blah, blah, blah. Is it ever going to touch it? No. Left 1/2 down 2, left 1/3 down 3, etc., etc. Okay? And now, if you have a highlighter or a pen or something else to write with, then let's go like this and let's dash in a line right there and dash in a line right there. What are those called? Everybody tell me. They're called asymptotes. So the one that looks like this, which is vertical, you guys, it crosses the x-axis. So everybody go x equals. And where does that cross the x-axis? At 0. And then the one that's horizontal crosses the y-axis. Where does it cross the y-axis? At 0. Okay? So the domain, we wrote x can't be 0. Remember, you start at the left. You guys start at the left and travel to the right. Is the domain everything but 0? Yes or no? Yes, it is. Now do the range, which is y. Start down and move up, and now shout out, what is the range? But the range is y, right? So y cannot be 0. And that's it, okay? Now, we're going to do it in a much different way, but that is a rational function, okay? It's kind of curvy in that. We're not going to use a table of values when we do it. Oh, I know what I was going to ask you. Is that 2 graphs? Or is it 1 graph? What is it? It's just 1 graph. Yeah. Okay, find the domain. Okay. Now everybody freeze right here and let's talk for a second, because domain is tough, and it was tough for some of you guys. When you're looking for domain, how many things do you look for? 3 things. A fraction with an x on the bottom, an even root on the top, and an even root on the bottom. We'll look at A. I don't have any even roots, but I do have an x on the bottom. What do I know about the bottom? Cannot be 0. So I'm going to go x plus 3 cannot be 0. So x cannot be -3. That easy. Okay. Now, I'm going to listen to this, and I want to see if anybody can answer this question. And if this confuses you, then don't worry. X cannot be a -3. I have to restrict x from ever being -3. I can do that in one of 2 ways. And you don't have to worry about which one it is at this point. But x equals -3 is either going to be a this or a that? Does anybody know the two ways I can restrict x from being a negative 3? It's going to be a horizontal asymptote, no, a vertical asymptote, or it's going to be a, what is it? A hole. Yes. And right now, I don't want you to worry about which one it's going to be. I just want you to know that those are the two ways that we can restrict an x value. Okay? Yes, honey?
So how come we have to graph the negative side too if the graph isn't y equals negative 1?
Say it again.
So like on the very top one,
Okay.
example we did, why do we graph the negative side if the equation's not negative?
It's not that the equation is negative, is that I have to graph this thing over the entire xy axis, and sometimes x can be positive and sometimes it can be negative. So I was just using tables to get a full picture of what it looks like. So just because the equation doesn't have a negative doesn't mean that x can't be negative. Does that make sense? Okay, it's a good question. I want you to know that I don't think that's ever going to be an issue for you because we're not going to use a table when we graph. Okay? Okay, question B, find the domain. Everybody go x to the second plus 3x minus 4 equals 0. There's something wrong with my statement. Someone tell me what's wrong. It cannot be 0. Yes. And now I'm going to factor it, and it's going to go to an x and an x. The 4 is going to go to a 4 and a 1. The signs are different. The biggest is a positive. So my restrictions are x cannot be 1, and also x cannot be a negative 4. It is acceptable to write your answer like that, okay? We went round and round and round, and I asked them specifically, is it acceptable to write it like that? And they said yes, okay? So I know we're good. Okay, vertical asymptotes. Look at your little paper, okay? So we're down on step 4. It says vertical asymptote. We're probably going to have to edit this because, yeah. I think somebody went through and edited it after I made this, and I don't like it. So see where it says 4, vertical asymptote? Part B, I just want you to write down the words bottom equals 0. Okay? Bottom equals 0. Go get a drink. Yeah. Okay? Go get a drink. I want you to stand up and go walk down the hall.
Good. That helps me.
I'm going to lose you again.
I'm sorry.
And this is so important. I want you to learn. Go walk.
I'm good now, I promise.
Do I have to drag you out of this room?
No.
I will drag you out. Don't let him fall asleep again.
Alright.
Okay, watch him. Okay, find the vertical asymptotes. Look right here. The denominator equals 0. That's what you do. So fill that in on that little paper because this is not my good paper, but we can edit a little. Okay, so to find the vertical asymptote, you go x plus 2 equals 0, pull it over, x equals negative 2. And now this is what some of you are saying in your head. Now I'm confused because up above you told me it can't be, and now you're telling me that it is equal. Okay, well here's why. Take your pencil and sketch a graph and come over to the left 2. And then I want you to dash in that asymptote. So we have an asymptote at x equals negative 2, which restricts the x value from ever being a negative 2. So x can't be a negative 2 because it's an asymptote. Who says, I understand what you're doing? Okay, great. Okay, question B. You always just look at the bottom. Okay, so you just take the bottom, x squared minus 9 cannot be 0. Okay, now you can factor the x squared minus 9, or you can pull the 9 over, whichever one you want. I'm going to pull the 9 over. So I'm going to say x squared equals 9, cannot be 9. And then I'm going to square root it, and I'm going to say x cannot be 3. Is that correct? What's missing? Plus or minus. And that's the risk of square rooting, is that you're going to forget the plus or minus, okay? So if you're the person that takes the square root, you have to do the plus or minus, okay? Yes?
Why is it cannot equal?
It should be equals, thank you. Sometimes when I get if I get one hand in the air, I'm like, okay, they have a question. And then if I get more than one, I'm like, what did I do wrong? So I had 3 hands up. I should have known. Okay, everybody go like this. Go to the right 3 and go to the left 3. And then I want you to take, I'd really love you to have a different colored writing utensil. Even if you have a pen in your bag, if you have a red pen, that would be awesome. But just something to let that asymptote kind of stand out for you. Okay, so you don't have to, but I think it's helpful. Okay, question C, find the vertical asymptote. So you go x to the second minus 4x plus 4 equals 0. And then I'm going to factor. So it goes to an x and an x. Signs are the same, they're both negative. 2 and 2 multiply to give me 4 and add to give me 4. So I have a vertical asymptote at x equals 2. And yes, it's listed twice, but I'm not going to list it twice. Today on your homework, you guys, that's all you have to do. Literally, you're done. But next time I see you, which would be Monday, you're going to actually have to graph it. So we're going to start looking forward to what the graph is going to look like, okay? Which would be that. Okay, question D. Find the vertical asymptote. Everybody go x squared plus 4 equals 0. I can tell right now that it's not going to work out. I can tell right now. How can I tell? Because the only way that x squared plus 4 is a 0 is if x squared was a negative 4. Negative 4 plus 4 is 0, right? Can something squared give me 4 or 0? Can something squared give me a negative? No. Okay, so is it going to work out? No. So I know my vertical asymptote is going to be none. Okay, now if you don't see that, so you don't have to show work if you can see that. If you don't see that, let's write this down, guys. Everybody go x squared equals negative 4. And then I can see that I'm square rooting a negative, which is going to give me an imaginary. And am I really going to list an imaginary vertical asymptote? No. Okay, odd and even vertical asymptote. Okay, let me ask you again. Did you do this in your math class last year? Raise your hand up high if you did. Okay, raise your hand up high if this was a little confusing or more than a little confusing to you. Let me see where we're at. Okay, so some of you, not a lot, so that's good. That's good. Hopefully we'll be good. Okay, so look at this one right here. Find the vertical asymptote. So it's x equals negative 2. Okay, now take that red pen or the pen that you grabbed or whatever you've got, and I want you to dash in that vertical asymptote. Okay. Is the asymptote even or odd? Everybody look right here. See this x plus 2? Do you see how you only have one of them? One is odd. So that is an odd vertical asymptote. Okay, everybody look right here. Eyes forward right here for me, okay? Okay, my body is the asymptote. My hands are the graph. If the bottom exponent, when you put it in parentheses, is odd, here's what it's going to look like. Look, the graph comes towards the asymptote on each side, and one goes up and one goes down. So it's either going to look like that, or it's going to look like that. I don't know which one, but I know they're going to go in opposite directions, okay? The rest of the information will help me to figure out what goes where. Who says, I understand that? Raise your hand. Okay, great. Look at the next one. Take the denominator and set it equal to 0, and I again get x equals negative 2. Take your red marker or whatever you've got and dash that in. And now you look at the exponent, and the exponent is even. So this is an even vertical asymptote. Okay, everybody look right here again. Watch the picture. Okay, my body's the asymptote, my hands are the graph. Even means it goes towards it on both sides, and it goes the same. So they're either both going to be up or they're both going to be down. And I don't know which one it is. I have to fill in the rest of the puzzle to figure it out. Okay, now go back up to question A, B, C, D, and we're going to figure out if these are even or odd. Okay, everybody look at A and just tell me out loud, is it even or is it odd? It's odd. So write in the word odd. And that's because the x plus 2 is raised to the first. Okay, now this actually, I made a mistake on B. You cannot write your vertical asymptotes like that. I am positive that they will take off points. So you cannot do that. For domain restrictions, you can. For asymptotes, you cannot. So erase, if you highlight it, just kind of scribble, and you have to write it as x equals -3, comma, x equals +3. I am 100% certain they will take the points off if you do that. Okay, so how many -3s do I have? I just have one. A better way to do this, guys, look right here. See the x squared minus 9? That factors to x plus 3 times x minus 3. So that gives you an x equals -3 and a +3. So the -3 came from here, exponent's 1, that's odd. X equals 3 came from here, exponent's 1, that's odd. So they're both odd. Okay? Next one. Question C. You tell me, even or odd? Even. It's actually even. And this showed up. We'll do an example like this on Monday. But this showed up on one of my finals, and it knocked out half my student. They missed it because they didn't recognize, oh, that's even. So they were trying to graph it as if it were odd, and it wasn't working out. Okay? All right, here we go. So, yes, sir.
Wait,
I'm so glad you're awake. He's awake and he's asking questions. It's amazing.
Wait, so why would B be odd then, like, if it says x squared? Oh, yeah.
So it's not necessarily the exponent. It's how many times x equals -3 is a solution. So right here, the -3 came from there. What's the exponent of that guy? 1.
Okay.
1 is odd. Does that make sense?
Yeah.
So you have to look down to where it's factored to determine the question, okay? To determine that. Okay, here we go. Moving on. Okay, non-vertical asymptote, okay? A non-vertical asymptote is either a horizontal asymptote, okay, or can't remember if they call it oblique or slant. I think they call it a slant. It's an oblique or a slant, okay? Which it's a horizontal or a slant. And a slant is the same thing as oblique. Just know that slant and oblique are the same thing, okay? Okay, so what is a horizontal asymptote? Well, it's like this, guys. Everybody draw an XY axis. Then I want you to take your red marker and I want you to dash a horizontal line. But then I want you to take your eraser. You probably just use pen, so maybe you can't. But I can erase, and so I'm going to get rid of the middle part of my horizontal asymptote. Now, I don't know if your teachers have done that for you in the past. I always get rid of the middle, okay? Why do I get rid of the middle? Does anybody have any idea why I got rid of it? It's right here. You can cross it. Can you ever cross a vertical? Tell me that. You can never. But can you cross a horizontal? Yes, you can. Okay. So your graph, like if I had an asymptote, say like that, your graph might actually end up going like down here, cross through, down here, cross through. So you can cross through the horizontal, but you cannot cross through the vertical. So that's why I always leave it open. Okay. All right. So here's how you do it. Here's what I want you to remember. Okay. I'm going to ask you, I'm just going to keep drilling you and asking you, how do you find this? So I'm going to say, how do you find a horizontal asymptote? And your response is going to be biggest over biggest. So you're going to take the biggest exponent over the biggest exponent. Okay. So for example, if we had y equals x to the third minus 1 over x to the second plus x. Okay. The biggest exponent on the top is a 3. The biggest exponent on the bottom is a 2. The top is bigger. So if the top is bigger than the bottom, there is no horizontal asymptote, and it's actually an oblique. Right there by oblique, I want you to put or slant. It's the same. Okay? Well, the easiest scenario is this, guys. Look, what if you have y equals x to the second minus 1 over x to the second plus x? They're the same. So then you just go x squared over x squared is 1. So it would be y equals 1, okay? If the bottom is bigger than the top, so if it's like this, okay, then it's y equals 0, okay? So I think what you're probably going to have to do is you're going to have to memorize this. And I'm going to walk you through it a little bit. I actually don't have it memorized. I just think through it every time I do it. Probably it's better that way. Okay, here we go. Determine the non-vertical asymptote. Okay, so I want everybody to go y equals, okay, the biggest exponent on the top is a 1 and the biggest exponent on the bottom is a 1. Now, this was not a good problem right here last semester. My students said that the answer was y equals 1. Many of my students. It's not y equals 1. Can anybody tell me what that is? Yeah, biggest exponent on the top is a 5x. It's 1, so you have to pull the whole term, so it's 5x. Biggest on the bottom is an x. Well, then those x's cancel out, and that does not give me y equals 1, guys. It gives me y equals what? Y equals 5. Good. Now that's your answer, okay? But I'm going to make you go a step further just on these notes. So I want you to draw an xy axis. I want you to come up 5, and I want you to dash the right, and I want you to dash the left. And I want you to leave the middle open. This is what I need you to know. Everybody look right here. What does the horizontal asymptote tell me? It tells me as x gets big right here, my graph goes to that line. As x gets small, my graph goes to the line. Really? Is it? I'm just teasing you. I got that Amber Alert last night. Did you guys? Well, and then I was like, oh my gosh, let's look so we can help. And you can even access it. Could you guys? I was trying to click it, and then they were like, click here. And I'm like, yeah, I'm not doing that. It's starting to look bogus. I'm like, I'm not doing it. But everybody in my whole house, their phone's like, ah. Did that happen to you guys too? Yeah.
Wait, why did you just do one but no one else did?
I don't know, because maybe his ringer, was you on vibrate? Yours was off. Yeah, sometimes I think it's such an emergency it pushes past even though. But I don't know. I didn't get anything because my watch didn't go off, so I don't know for sure.
It's the same one from last night, though.
Same weird bogus thing.
Yeah, great.
Yeah. Yeah, all this like letters that didn't make sense. Yeah. Anyway, okay. So that's what a horizontal asymptote means. So everybody look right here. So actually, I'm just going to leave it. You don't know if you're below. You don't know if you're above. But you know as x gets big and x gets small, that's where my graph is going. And then there's going to be funny stuff going on in the middle. Who says I understand what you're saying? Let me see. Okay, great. Let's do this one. Biggest over biggest. So everybody go y equals 2x squared over 4x squared. You guys, this is the best scenario, is for the exponents to be the same because it's so easy. All you do is just get rid of them, and your asymptote is y equals 2. It's not 2. 2 is a very common error, so be careful. It is 1/2. Good. Let's draw a very quick sketch, okay? XY axis, up to a 1, halfway up, dash a line, but leave your middle open. Okay, some people, it makes them stressed out to leave the middle open, so they want to go all the way through. That's fine, but I don't like it because then you're going to go up to it and potentially have to cross it, and you're going to go, oh, I'm not supposed to be crossing that thing. So that's why we keep it open. Okay, okay, question C. Biggest over biggest. Okay, everybody go y equals 2x over x squared. Okay, now, if you reduce that, you get y equals 2 over x. Okay. Now I want to explain something to you. I want you to write it down this time, and you never have to write it down again. And I just want to teach you how to think about it so you don't have to memorize it. I don't have it memorized, but I think about it and I'm like, oh yeah, I know what it is. Okay, look what I'm saying. A horizontal asymptote or a non-vertical asymptote is as x gets big and as x gets small, where does my graph go? That's what that tells me. Who says I understand exactly what you just said? Okay, great. Let's make x get big. So let's go 1, 2, 3, 1,000. I know that last one was a big jump, but you're going to see what I mean. If x is a 1, 2 over 1 is a 2. If x is a 2, 2 over 2 is a 1. If x is a 2, if x is a 3, pardon me, you get 2/3. If x is 1,000, you get 2 over 1,000. So as x gets big, y is getting closer and closer and closer and closer to, tell me, 0. That's why it's y equals 0. So of course you don't have to do all that. I just do it in my head. Oh yeah, the x is left on the bottom. That means it's going to go to 0. Okay? Okay, next one. Biggest over biggest, you go y equals x to the third over x to the second. Okay? And then if you reduce that, you get y equals x. Okay, well, y equals x, I've never done it this way. I think I'm just going to talk about it. What does the graph y equals x look like? Looks like that, right? So is it going to be a horizontal asymptote? No, this is not horizontal, right? So it's going to actually be an arrow, and it's going to be left down, right up, okay? Now, we're really not going to do it that way on Monday, but at least you know kind of what way it's going to go, but then you actually have to come up with the precise equation for it. But at least we have a general idea. So the non-vertical asymptote is actually going to be a slant asymptote, and we're not going to find it yet, okay? We're not going to find it. Okay, oblique. Right there where it says oblique, I want you to write the word slant. I need to look up what they call it. It's an oblique or slant, it's the same thing. Okay, so here's what you do. You do long division, okay, and then write a note to yourself that says you throw out the remainder. Okay, find all the asymptotes. Well, that's going to be a vertical asymptote and a non-vertical asymptote. Now, I just want to make something clear to you. Go like this, just for this example. A non-vertical asymptote is either a horizontal or a slant. You could never have two. Think how silly that would be. If you can understand what I'm going to say right now, boy, it's so good. Look right here. Could you have both a horizontal and an oblique? Like, where am I supposed to go? Am I supposed to go here? Am I supposed to go there? Am I supposed to go here or am I supposed to go there? So you could never have both. It's either one or the other. Who says I understand that? Let me see. Okay, yay. Okay, so vertical asymptote. Remind me again, try not to peek at your little paper or your notes or anything. How do you find a vertical asymptote? From the bottom, right? So your vertical asymptote is going to be x equals 1. To check your non-vertical, all you do is biggest over biggest. So that's 2x squared over x. Now just think about it. The top is bigger. So this is going to reduce to y equals 2x. So it's not going to be a horizontal. It's going to be a slant. Y equals 2x is a line that looks like that. So I know my end behavior is going to be left down, right up. Now, I've never, ever had my students make that connection, but I feel like you guys are all so smart. It's just everything is clicking so well in this class. I know it's going to be a line that goes that way, okay? I just have to figure out the exact equation now, okay? Okay, so let's do it. The x minus 1 goes on the bottom. On the inside, you have 2x to the second plus 3x plus 1. Now, I need to say something, so freeze right here. When you're doing long division, you look at the outside. Please listen, okay? If you're doing the long division, you are not listening to me, and it's going to cause you to miss a problem. I promise you, okay? On the outside, the biggest exponent is 1. You have to have a 1 and a constant. Do I have an exponent of 1 and a constant? Yes. Look at the inside. Biggest exponent is a 2. I have a 2 and a 1 and a constant, and I'm good. If something's missing, what do I have to do? Fill in a 0. Now listen what happened 2 semesters ago. I was saying this to my students. They were doing the long division just like half of you guys were. They didn't listen. There was a problem on the final where if you didn't fill the 0 in, you missed it, and they missed 2/3 of the questions. I'm not kidding. But now I've inputted that question into next time's lesson, so hopefully we'll come across it and you'll remember, okay? Okay, what do I multiply by x to get 2x a second? That's 2x. Distribute, and I get 2x to the second minus 2x. What do I do now?
Subtract.
Change your signs, right? Those cancel. 2x plus 3x is a 5x. Tell me what to do now. Bring down the 1. What do I multiply by x to get 5x? That would be a 5. Then I distribute. I get 5x minus 5. Change my signs. Those cancel. I get a 6. What's the 6? How do I know it's the remainder? There's nothing else to bring down. And what do I do to the remainder? I throw it out. So my non-vertical asymptote is y equals 2x plus 5. That's my answer, and I'm done. Now, I'm going to take it one step further. So everybody just freeze right there. I'm going to take it just a little further. So on Friday, when we put all these pieces together, you don't panic, okay? Yes, honey?
How come we changed the signs when we were doing the long division?
Say it really loud.
Why did we change the signs when we were doing the long division?
Because when you do long division, like if I take 2 into like 32, I go 2 goes into 3 one time, 2 times 1 is 2, and then I subtract. So it's this requirement of the subtraction that has me change it. Okay, great. Yes, sir?
Can you do synthetic division on that?
We say it really loud?
Can you do synthetic division on that?
Not yet. Not yet. Okay? Anybody else? Okay, draw an XY axis over here. Okay, just somewhere. Come right here to the right one, and I want you to dash that vertical asymptote. Okay? Freeze right here and let me ask you a question. You guys are so smart. I know I can throw more things at you than I typically would do. How many pieces will there now be to my graph? Now that I know I have one vertical asymptote, how many pieces will I have?
2.
I'm going to have 2. I'm going to have one on the right and one on the left, always. If I have 2 vertical asymptotes, how many pieces will I have?
4.
3. One on the right, one on the left, and one in the middle of those. If I have 3, what will I have? 4 pieces. Okay, if you didn't understand, don't worry, we're going to go through it. Okay, let's graph y equals 2x plus 5. Everybody come up 5 and make a dot. And then the slope is 2 over 1. So you're going to go up 2 and right 1, down 2 and left 1. Now, before you make that line, remember that this is replacing the horizontal asymptote. And the middle of the horizontal asymptote is supposed to be opened. So graph it something like this. Oh, that, I want that guy to be, I just want you to see more clearly. Okay, so I've got a vertical asymptote and then I've got the oblique. I'm going to extend this guy a little bit more. You get the idea. Okay, who says I'm with you? I'm getting this. This is a super important lesson. Okay, find the slant or the oblique asymptote. I know I'm going to have an oblique because the top is bigger than the bottom. Okay, so everybody go x minus 3 divided into x to the second. I don't want anybody to say anything yet. Don't say anything. Let's just roll. Okay, what do I multiply by x to get x a second? That's an x. Distribute. I get x to the second minus 3x. Change my signs. I get a 3x. That's my remainder. And my oblique or my slant asymptote is y equals x. And I lost every single point. This is what happened to my students like 2 semesters ago. And it was super painful because I think it was a 15-point question out of 150 or 200. It was 10% or less, like between 7 and 10%. It was so painful. For one little itsy bitsy thing, what did I not do? Remember, you guys were starting to long divide, and I said, stop and listen to me and make sure you don't do this. What didn't I do on this problem? Come on. Yeah, I have an x squared, but I don't have an x, and I don't have a constant. I have to fill those in. So is the 3x really the remainder?
No.
It is not the remainder. So I do get a 3x, but now I have to bring down the 0. What do I multiply by x to get 3x? That's a 3. I get 3x minus 9. Change my signs. Now I get a 9. That's the remainder. So my oblique asymptote is actually y equals x plus 3. You have to be so careful. Okay, let's talk about wholes. The only time you're ever going to have a whole is if something reduces. That is the only way you're ever going to have a whole. Okay, now I'm going to teach you wholes. We're going to have graphs that have holes in them. I have never one time, not one, in 8 years of teaching this class, so that's 16 semesters, I have never one time seen Weber give a hole. So I don't think you're going to see a hole. But I'm going to give you holes because we got to be ready, okay? But I don't think it's going to happen on yours, okay? Okay, here we go with domain. Now look at your little paper. We haven't even looked at the paper, okay? So here we go. This is kind of like the beginning almost to the end, okay? So step 1 is to factor. So everybody go f of x equals the top factors to x plus 1 times x minus 1. The bottom factors to x plus 2 times x plus 1. Okay, I did not want that to happen. I think I edited this. We're going to make this a 3. Oh, yes, I do want that to happen. Yes, I do want that to happen. Never mind. We're good. Okay, step 1, factor. Step 2, should I cancel? Look at the order. Should I reduce and then find the domain, or find the domain and then reduce? What does it say? Find the domain and then reduce. So the domain is x cannot be equal to, tell me everybody, shout that out. -2 or -1. Okay, so that's the domain. Now I reduce. If it reduces, and I have exactly an x plus 1 here and exactly an x plus 1 there. Everybody freeze. The second it reduces, I know I have a what? A whole. So before you even write down that reduced equation, I want you to come over here to where it says whole, and I want you to fill in the x. What is the x coordinate of the whole? Tell me. -1. How did you do that? What canceled? Set it equal to 0, you get a -1, okay? The reduced function is now f of x equals x minus 1 over x plus 2, okay? Where it says number 3, see where it says 3, where it says reduce if possible? Write a note to yourself right there on the little paper that says use this formula from now on. So what I'm saying is, see this green reduced function? I'm going to use the reduced function for steps 4, 5, and 6, and 7. So this original guy, don't do this to your paper, but this original guy right here, he's gone. This guy right here, he's gone. Don't cross yours out because you'll confuse yourself, but don't ever look back. Once you reduce it, you're good, okay? Next step. Let's find the y coordinate of the whole. So we're on step 4. Someone tell me how to find the y coordinate of the whole. People get confused on this. Plug in the x, yeah. So everybody just go f of -1 is equal to -1 minus 1 over -1 plus 2. So that's a -2 over a +1, which is a -2. Okay, vertical asymptote. So we're on 4b. Try to remember without the paper. How do you find a vertical asymptote? The bottom. Look what people do. X equals -2. X equals -1. Why did they get that wrong answer? What was their error? That's what I want to know. What'd they do, buddy? They looked back at the original. You're supposed to look at the reduced. So x equals -1 is not a vertical asymptote, because remember at the beginning, I said that restriction, it's either going to be a this or a this. So the x equals -1 did not end up being a vertical asymptote. It ended up being a, talk to me, a hole. Yeah, it's still a restriction, but it's not an asymptote, it's a hole. Okay, non-vertical asymptote. Everybody write down y equals x squared over x squared. Talk to me.
They're the same.
That's wrong. X squared over x squared is wrong. Why is it wrong? I again used that original equation. It's the green one that I'm supposed to be using. Now on that it wouldn't matter, because either way I'm still going to get a y equals 1, but sometimes it's going to mess you up. So you've got to make sure you use the right one. Okay, now that's my answer and I'm done, but we're going to take it a step further. Okay, draw your xy axis. Come over here to x equals -2 and dash in that asymptote. How many pieces will I have to my graph? Tell me. 2. One part on the right and one part on the left. Okay. Come right here to y equals 1. That's going to be a horizontal asymptote, but I'm going to leave the center open. And then I have a hole at -1, -2. So that's left 1 and down 2. I have an open circle right there. There's one other thing that I have not been reconnecting to these problems I've been doing with you. Is that vertical asymptote, x equals -2, is it even or is it odd? It's odd because the exponent's a 1. So I know when it goes to the asymptote, guys, it's going to go like this, 1 up and 1 down. I don't know which one's which, but I know they're going to go in different directions. Okay? All right. X-intercepts, y-intercepts. Let's just go through it and then we're going to talk about what's on there. So guys, will you listen? I've been spending a lot of time looking at your midterm over and over and over again because we're getting closer and closer to taking that thing. So this stuff right here is all over your midterm, which is so good. They give you an equation, give me the x-intercepts. Give you another equation, find the y-intercepts. Give you a third equation, tell me the vertical asymptote or asymptotes. Give you another one, give me the non-vertical asymptote. So they're just drilling you. On the midterm, this was a times what, this lesson? Tell me, like a 5?
Yes.
Yeah, this is a 5. That means there were 5 questions out of probably 30 on the midterm that came from this section. Big. Okay, here we go. Question 7. Find the x-intercept. I'm going to let y be a 0. To find the y-intercept, I'm going to let x be a 0. Now, the y-intercept is easy, and it requires no work. Okay, so everybody look right here. Let x be a 0. Don't mark your paper up, but I'm going to mark my paper up. If x is a 0, that goes away, that goes away, that goes away. They're all zeros, right? What's left? 1/6. That's all you have to do. Okay? Now, I'm going to try to explain something to you, and it's hard to explain, and it's also hard to understand. But if we can communicate, it's going to make your life easier. Okay, look right here. To find the x-intercept, you let y be a 0. So everybody go 0 equals 2x plus 1 over x squared minus 5x plus 6. If you never understand what I'm about to say to you, you can still recover. Because what could you do to this? You could just cross multiply right now. You could put a 1 underneath the 0, cross multiply to get it out. But there's an easier way. Everybody look right here. You don't have to write any of this down. I want you to just listen. If I have a fraction a over b, and that a over b is equal to 0, like that guy. I have a fraction equal to 0. How is the only way that a fraction will ever be a 0? Tell me. If the top is a 0. And that's the phrase I'm going to keep saying to you 15,000 times, and you're going to get so annoyed. And then I'm going to be happy that you're annoyed, because then you're going to remember. I'm going to say, how do you find an x-intercept? you let y be a 0, which is the same as letting the blank be a 0, and you guys are going to say, what's the blank? Top. So everybody just go 2x plus 1 equals 0. That gives you 2x equals negative 1. Divide by 2, x equals negative 1/2. If you write your x-intercept as x equals negative 1/2, they will give you nothing. Nothing. It's negative 1/2 comma 0. Okay, let's do the next one. To find the x-intercept, you let y be 0. To find the y-intercept, you let x be a 0. Okay, so if x is a 0, then look what happens. Goes away, goes away. What's that equal to, guys? 4. That's easy. So it's 0, comma 4, and you're done. Now, there are about 35 people in this room. I think it's like 38. So I should hear 38 voices. To find the x-intercept, you let y be a 0, which is the same as letting the blank be a 0, fill in the blank. Now, top. So everybody go x squared minus 4 equals 0. I'm going to factor x and x plus 2 and minus 2. So I get x equals negative 2 and x equals positive 2. Okay, come to the x-intercepts and go negative 2, 0, 2 comma 0, but I'm not stopping there. From last time's lesson, do those x-intercepts bounce or do they cross? They cross because the exponent's 1. Let's go back to this guy. Does that negative 1/2 bounce or does it cross? It crosses because the exponent is 1. Odd means cross. Okay, now we're pulling everything together. Okay, here goes question C. To find the x-intercept, you let y be 0. To find the y-intercept, you let x be a 0. Let's do the y-intercept. It's so easy. Just get rid of that x. 2 over negative 1, that's negative 2. To find the x-intercept, you let y be 0, which is the same as letting the blank be 0. What's the blank? The top. 2 equals 0. That's weird. What's the answer? None. Yep. Take your pencil, erase it. It's not going to work out because 2 is not equal to 0. Okay, next one. To find the x-intercept, you let y be 0. To find the y-intercept, you let x be a 0. Oh, I remember this. This is an edited problem from last semester. To find the y-intercept, let x be 0. Look, 0, 0, 0. Negative 5 over 2. Easy. To find the x-intercept, you let y be 0, which is the same as letting the top be a 0. Talk to me. It doesn't factor. So therefore the answer is none. Is that correct? Lots of people go, oh, it doesn't factor. None. What is it? Here we go. Quadratic. X equals. They did this to my students last semester. X equals negative 2 plus or minus the square root of. Please don't write 2 squared. What do I want you to write? 4. Minus 4 times 1 times negative 5 all over 2 times 1 is a 2. Now freeze. Am I allowed to just stick that whole guy in my calculator? You got to know this answer. Can I just punch? Yes or no? There is one big reason why the answer is no. Why not? When I do that, what kind of number am I very likely going to get? A decimal. And am I allowed to write in decimal if they don't ask for decimal? No. So can I just punch? No. Okay, see this right here? Take your highlighter and I want you to highlight that right there. I want you to always, 100% of the time, punch that in your calculator. You know why? Because my students are so bad at it. They're so bad at getting that number. So just use your calculator. So go 4 minus 4, parenthesis 1, close it, parenthesis, negative 5, close it, enter, and you get, is it 24? Are we done? No, keep going. 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3. These two 2's come out as a single 2. So now I have x equals negative 2 plus or minus 2 square root of, talk to me, 6 all over 2. Listen to my question. Can I cancel that 2 with that 2 and get -1 plus or minus 2 square root of 6 as my answers?
No.
No, because it's what? What's that word I told you before? It's rude. Did I tell you it was rude?
Oh, yeah.
It's rude. Yeah, it's rude. Who are you being rude to if you do that? The 2 squared is 6. It's rude. So you have to include that guy. Now can I reduce? Yes, because 2 goes into everything. So you have x equals -1 plus or minus 1 square root of 6 all over 1. Now, there are a lot of 1s in that number. Okay? In those numbers, there's 2 numbers. Some people know which ones you don't have to write and some people don't. If you don't know, leave them alone because they'll give you credit for them. There are 2 1s that I don't have to write. Tell me one of them. The 1 in front of the square root of 6. Why does that guy not have to be there? Because it's multiplied by the square root of 6. Multiplied by 1 doesn't change anything. What's the other one that you do not have to write? The bottom one. Why? Because you're dividing by 1, which doesn't change anything. Do not write this as plus or minus. So write it as -1 plus the square root of 6, comma 0, -1 minus the square root of 6, comma 0. If they asked you if they bounced or crossed, what would your answer be? They cross because they are each a solution one time. Let's come back over here. Oh, there's no x-intercept, so that's good. Okay, question 8 and 9, and we're done, and I have like not too much time. Okay, question 8. Find the x-intercept, the y-intercept, the vertical asymptote, the non-vertical asymptote of this guy. Okay, everybody go x-intercept, y-intercept, vertical asymptote, and non-vertical asymptote. To find the x-intercept, you let y be 0, which is the same as letting the blank be a 0, fill in the blank. Talk to me. Top. That gives me a 4, 0. You don't even have to show any work. Bounce or cross? Cross. Because I have 1 x minus 4. To find the y-intercept, you're going to let x be a 0. Don't cross your paper. I'll cross mine. Okay? Look. Goes away, goes away, goes away. What's left? A -4 over 5. Vertical asymptotes. You have to remember where they come from. Where do vertical asymptotes come from? The bottom. So I'm going to go x to the second minus 6x plus 5 is equal to 0. And now I'm going to factor. So it's going to go to x and x. Signs are the same. They're both negative. 5 and 1 multiply to give me 5 and add to give me 6. So I have a vertical asymptote at x equals 1, comma 5. Look at how I wrote that. Are they going to give you credit for that? No. They are not. No, they are not. Please don't write it like that. You get x equals 5. Are those asymptotes even or are they odd? They are odd because they both have exponents of 1. Everybody in the room, how do you find a non-vertical asymptote? What do? Biggest over biggest. So that would be y equals x over x squared. If the bottom guy, the bottom exponent is bigger, what is my asymptote? Y equals 0. And you're done. Yep. Okay. Let's finish 8 and then we're going to come back. Let's finish 9 and then we're going to come back up to 8 and draw a picture. Okay. Question 9. Find the x-intercept. Find the y-intercept. Find the vertical asymptote. And find the non-vertical asymptote. To find the x-intercept, you let y be 0, which is the same as letting the blank be 0, fill in the blank. The top. Everybody go x to the second minus x minus 12 equals 0. This is what happened on the midterm of the final. They went to find x-intercepts, and that didn't factor. That's what it was, I think. So then what do? Quadratic. Yep, but this factors. So it goes to x and x, and 3 and 4. The biggest is the negative. I get x equals 4 and -3. Please don't write them like that. So it's -4, comma 0 crossing, and 3, comma 0 crossing. To find the y-intercept, you let x be a 0. Goes away, goes away, goes away. -12 over -1 is positive 12. Yeah, that's a -3. Vertical asymptotes. Where do vertical asymptotes come from? Tell me.
Bottom.
The bottom. So that's x equals 1. Even or odd? Tell me. odd. Why odd, everybody? Exponents of 1. Let me finish and I'll come back, okay? Non-vertical asymptote, biggest over biggest. The top exponent is bigger than the bottom. There. The top exponent's bigger than the bottom. So what is it? It's an oblique or a slant, right? How do I find the oblique or slant? Long division. So I go x minus 1 into x to the second minus x minus 12. Those x-intercepts I wrote wrong. They are 4, 0 and negative 3, 0. I don't know what I said, but that's what they're supposed to be. What do I multiply by x to get x to the second? That's an x. Distribute x to the second minus x. Change your signs. They both cancel. Bring down the negative 12. I'm dividing by two things, and I only have one thing, and there's nothing more to bring down. So the negative 12 is my remainder, and I'm done. Y equals x. Okay, you guys, I think that might have just been one of the most important lessons we do in this class. Tons and tons and tons of questions on your midterm and final on this stuff. Okay, don't pack up yet. Draw your XY axis. Yes, you have a question. Go ahead.
So why do we have to do that long division? Because if we just put x squared over x, we would just got an x, and it comes out to be the same.
Because it won't always be that way. That's the best answer I got for you. Okay, let me graph real quick. Okay, 4, 0. Everybody go 1, 2, 3, 4, 0. Put a dot and put a C. Negative 3, 0. 1, 2, 3. Put a dot and put a C. Vertical asymptote. X equals 1. It is right there. And up at the very top, I like you to write the word odd. Y equals x is this line that looks like this. The slope is a 1. Looks like that. Leave the center open because we might cross it. And then the y-intercept is going to be clear up here. Like, I'm not even counting, but it's going to be somewhere like that. Now we're going to put the whole thing together next time. Am I good? Okay, let's go back and let's do the same thing for 8. I just want to make sure you understand what this is, okay? XY axis. I always graph my asymptotes first, by the way. I always do. So everybody go x equals 1, x equals 5. What am I going to ask you right now? Anticipate my questions. What am I going to ask you? I'm going to ask you how many pieces are on your graph. Pieces to your graph. How many will there be? 3. Right, center, and left. Okay? Don't pack up because we're not done. Okay, y equals 0 is right there. It's right on the x-axis. Leave the center open. 0, negative 4/5 is about right here. And 4, 0 is right here, and it crosses. Oh, and your asymptotes at the top, write the word odd. And now we're going to put the whole thing together. Okay? Question. Go ahead. So do you see how that's x equals 1? That came from here. Exponents of 1. 1 is odd. The 5. Remember, even or odd, remember my body was the asymptote, my hand is the graph. So odd means they go in different directions. Even means they go the same. Okay? Okay, have a wonderful, wonderful day, everybody, okay? You guys are awesome. I'm going to have you guys write down your happiness things over here, but just not right now because you have to go now. Bye.